Okay, folks, good morning. Jason and I are going to be outlining and actually demonstrating aspects of our cloud reference architecture. I have the semi-interesting part of highlighting some of the unique attributes of our architecture, but Jason has the fun part. He's going to demonstrate some of these capabilities right here on stage. So right now, as we speak, Jason is kicking off the demo, and he's starting a deployment of an application in a small private cloud that Andrew is making sure no one trips over the wires backstage. And Jason's using the IBM Workload Deployer, and we have a box sitting right here on stage. Now, this is the cool part. Part of Jason's demonstration is interactive via Twitter. So ready your laptops and cell phones and tweet to IBM Cloud. Your tweets are actually going to drive live load as we demonstrate in a few seconds concepts around elasticity. And you're going to see your tweets pop up on the dashboard, so keep it clean, architecture. So enough of me talking here, folks. I want to turn it over to my colleague and friend, Jason McGee, and Jason's going to take you through a demo. Good luck, Jason.
Thanks, Jerry.
You don't need luck, actually. Make it happen.
Thanks, Jerry. So for the past few minutes, as Jerry's been talking and taking you through these principles and attributes of the cloud, you've been staring at this dashboard over here on the left. And let me take a moment to explain what you've been watching on that dashboard. Behind the dashboard, we have a private cloud that Jerry mentioned running under the control of IBM Workload Deployer. Now, Workload Deployer is a new offering that builds on the work we delivered with WebSphere Cloudburst Appliance and enables you to build an application-aware private cloud. Workload Deployer supports a bring-your-own-hardware model where you use the Deployer appliance to manage a collection of hardware resources that you already own. Workload Deployer enables the deployment and end-to-end management of applications with built-in elasticity and a radically simplified self-service user experience. It comes preloaded with a collection of patterns that enable the deployment of web and database applications and many of our middleware products. Now, getting back to the dashboard. In the top right, you see 3 applications that are currently running on the cloud, including the application that I kicked off as I walked on stage with Jerry, which is shown in red. Notice from the throughput graph at the bottom that when I started the application, it's already up and running and handling load. IBM Workload Deployer has fully provisioned the application from nothing to a running system based on WebSphere Application Server and DB2 in about 8 minutes while we were up here on stage. That kind of speed allows you to transform your development, test, and production processes. At the bottom of the dashboard, you see statistics about the running applications, including throughput and latency, and about the cloud resources, including the number of active servers and the utilization of the cloud. At the top left, you see your incoming tweets that have been loading up the cloud with active requests since Jerry began talking. I can see you've done a good job sending in some tweets to the cloud. Now, Jerry talked about the importance of patterns and about the importance of the cloud being application aware. So to understand the role that patterns play, I want to look at how we deployed that first application that I kicked off as we walked on stage. So here we have an application pattern in IBM Workload Deployer. One of the key capabilities of Workload Deployer is the ability to quickly and easily define an application you want to run on the cloud. In this example, we have a really simple pattern with a single web application that talks to a single database. Now, using Workload Deployer, it's simple to create this application pattern. The web application component contains the WAR file that implements the application logic. The database component contains the schema of the application's data store. And the link between them declares the usage of that database by the web application. This pattern describes in simple terms everything you need to deploy and manage that application on the cloud. Once completed, a single-click deployment will launch an instance of the application on the cloud managed by Workload Deployer. Now, when I deployed the application earlier, the Workload Deployer created all of the middleware infrastructure necessary to support this application, as shown in the diagram there in the bottom corner. And this included creating the application server, the database server, and all the necessary connections between them. Remember, it was able to do this in only 8 minutes. Now, this deployment included not only the application itself, but all of the necessary infrastructure to manage and monitor this application throughout its lifecycle. Workload Deployer does not just handle standing up the application, but it ensures that application stays up and continues to meet demands that are placed on it. Now, that application that I deployed is really simple, a simple configuration, one that's not ready to handle the load that you are putting on it via the stream coming off of Twitter. So we need to figure out how to add elasticity to the application to meet the demands that you're placing on it. So let's see how we do that. So Workload Deployer supports the notion of policies that you can attach to your application and describe the behavior that you need when that application is running on the cloud. With Workload Deployer, adding these policies is really simple. So to get elasticity, we go back to our pattern, and we simply add a scaling policy to the application. This scaling policy has a few simple properties that allow me to control how I want that application to behave when demand increases. I can set the initial number of instances of the application, the min and max size of that application under load, and the conditions under which I want that application to grow and shrink. In this example, using CPU. I added this policy to the second instance of the application on the dashboard, and here is the environment that Workload Deployer created for me on the cloud. So Workload Deployer uses the policy information to determine the appropriate middleware design needed to make that application elastically scalable. This included creating a clustered application server to host the web application, a distributed cache for holding application state, like HTTP session data, and making it fault tolerant and horizontally scalable, and an edge of network proxy for load balancing and failure recovery for incoming traffic. This elastic deployment takes about 8 minutes, from nothing to running on the cloud. Once deployed, Workload Deployer will continuously monitor the application, detect and recover from failures, and increase or decrease the size of the topology to ensure that the appropriate amount of resources are available for that application as it runs on the cloud. If we look back at the dashboard, you can see that elasticity in action. So if you're paying attention, as the load increased due to the Twitter request stream, you can see that Workload Deployer automatically scaled up the application from 2 nodes, as it started in the beginning, to 5 in a couple of steps. Right? So it grew the size of that environment as the demand increased. You can see also in the graphs as the latency improvements as these new resources came online. So we get some pretty powerful behavior with a simple change to our application pattern. So what's up with that final application on the cloud? That one's a little bit different than the others. The third application, shown in green, is a SOA application composed of a business process utilizing web services. Workload Deployer supports the notion of versatile workloads that Jerry discussed and can be extended to support these new patterns. This allows you to deploy a variety of different workloads on the cloud. One of the challenges SOA applications confront is how to control usage of critical services exposed as part of your business process. With Data Power, IBM offers some compelling edge of network capabilities to control how those web services can be accessed. So to demonstrate how these two capabilities can be brought together, we want to protect that web service against the threat of an XML denial of service attack, like somebody sending in a set of oversized XML payloads. So just like with elasticity, Workload Deployer makes it really easy to add policies to your application to control the desired behavior. So to protect the web service, we added an XML denial of service threat protection policy to the application and configured the type of threat we wanted to protect against. We did this earlier, and we deployed the application to the cloud. The policy enables the application to interact automatically with the Data Power appliance and have Data Power enforce the application protection. You can see from the dashboard on the right in the red line that around the 5-minute mark, the SOA application was hit with an attack that lasted about 3 minutes. Throughout the attack, the application throughput and latency were unaffected, as shown by the green graph lines to the left. This attack was blocked at the edge of the network and never actually reached the actual application running on the cloud. So with IBM Workload Deployer, you saw how we can quickly and simply deploy applications to the cloud, how we can make them elastic and secure, and how we can manage them automatically under changing conditions, and how we can handle a diversity of workloads. All of this can be accomplished using your existing virtualized infrastructure from a simple-to-deploy self-service appliance. The attributes of cloud computing that Jerry discussed are all about agility and efficiency, and IBM Workload Deployer delivers those attributes today for your applications. So come and see the Workload Deployer in the Solution Center, in the Cloud Zone of the Solution Center, along with a number of other leading technologies for public, private, and hybrid clouds. There are over 120 technology sessions about cloud at the conference, and so there's plenty of content for you guys to learn more about what we're doing. I encourage you to take advantage of the opportunity to spend some time with experts that are here, myself, my team, and many others, to learn about the breadth of cloud computing technologies available for IBM. Thanks a lot for your time. Enjoy the rest of your day.